আচ্ছা চলো আমি আজকে মে-জুন 2025 এই কোয়েশ্চেন পেপারটা 0620 যারা IGCSEর স্টুডেন্টস আছো 45 minutes you have 45 minutes time to finish this paper. চলো দেখি এই পেপারটা আজকে সলভ করি। দেখো question number 1, an ice cube melts. What happens to the molecules of water in the ice cube? So if an ice cube melts, then they dissolve. What happens to the molecules of water in the ice cube? See, what happens to the molecules of water they are asking. So will the water molecules dissolve or they will gain or lose on energy? So they're gaining energy so that they are transforming to a liquid, because solid has less kinetic energy than the liquid. So many of you can write they dissolve, but actually the answer will be they gain energy. So this is the first thing. Second, see, a sample of liquid X is heated to a temperature above its boiling point. X is then cooled so that it condenses and then freezes. Which graph describes the change in temperature of X over time? So change in temperature and time. See, so they are asking a sample of liquid X is heated to a temperature above its boiling point. So above the boiling point, if you heat something, it will turn to a gas, right? So you can write here gas, then X is then cooled so that it condenses and then freezes. Which graph describes the change in temperature X over time? So first you have heated so that it turns into gas, then it is cooled so that it condenses, then freezes. So you see, when you heat X, so it will turn into gas. Then see, when you are condensing, it is turning into liquid. Then when you are further cooling it, it is turning into a solid. So B should be here, the only correct answer. Rest of the graphs are not, up to the point 2. Next question, very easy one, I guess. Which row gives the number of protons, electrons, and neutrons in an atom of zinc? So if you see zinc is 30. So proton number, the atomic number of zinc is 30. So zinc has 30 protons. Then since it is zinc, so it will have the same number of electrons, so 30 and 30, and neutrons. If you look at the periodic table at the end of the book, question paper, so if you look at, so zinc, you see this one is zinc is 65. So if we come back, so if it is 65, then you need further 35 neutrons. So the nucleon number is equal to proton plus neutron is the nucleon number. So this one is pretty easy for you. So A should be the only correct answer, 35 and 35, right? Next question, if we go, which particles have the electronic configuration of 288? So 288, you can see it has complete outer shell. So argon, argon is 18 atomic number, so it is 2, 8, and 8. Aluminum 3 plus, it has 13 13 atomic number, so it should be 2, 8. Sodium is 11, so it is again 2, 8, as you have 3 plus and 1 plus charge here. Chloride is 17, so it should be 2, 8, 8, as it has 1 minus charge here. So 1 and 4 should be the only correct answers. Okay, so number 4 done. If we go to number 5, a sample of element Q has 2 isotopes. See, the relative mass of isotopes are given, and percentage abundances are given as well. What is the relative atomic mass of this sample of Q to 3 significant figures, right? So if we write here, relative atomic mass AR, is the mass of first isotope into its percentage abundance, then plus mass of second isotope into its percentage abundance. So if you, it will go on and on. If you have 2, 3, 4, 5, 6 isotopes, so it will go on and on further. So that's how it will go. So if we write mass of the first isotope, then you see mass of the first isotope, if you look at, it is 238. So it is 238 times its percentage abundance is given 66%. 66% means 66 divided by 100, plus you have 244 here, second isotope, mass of the second isotope, into its percentage abundance is 34 divided by 100. So if we calculate, then it's 238 times 66. So if we calculate, it will be, so it is 238 times 66 plus 244 times 34, which is divided by 100. So it is 240.04. So the answer is 240.04, but they are asking for 3 significant figures, you see. 3 significant figures. So it will be 240 if we round up. So this is very important, how we should calculate the relative atomic mass of an element, provided they are giving you the isotopic abundance and they are giving you the relative atomic isotopic mass. So number 6, if we proceed, with statement about silicon peroxide is correct. Silicon peroxide, silicon peroxide is a giant covalent structure. So giant is the structure and covalent is the bonding. So it conducts electricity because it contains delocalized electrons? No, because it is a giant covalent structure. We have in our syllabus, we have 3 giant covalent structure, right? Like silicon dioxide, diamond, and graphite. So only these 3 in O-levels IGCSE syllabus. So only graphite conducts electricity from the giant covalents, and diamond and silicon dioxide, they do not. And all the organic chemistry substances, in organic chemistry, the substances, molecules, and compounds we have studied, these are all covalent substances, whether it is carboxylic acid or an aldehyde. Sorry, aldehyde we didn't study. Carboxylic acid or alcohol or alkene. These are all simple covalent substances that you need to keep in mind. So it does not conduct electricity, silicon dioxide. And it is sand basically. If we see around us, it has a giant covalent structure with each silicon atom bonded to 4 oxygen atoms. So each silicon atom, if you look at the structure, it's something like this: silicon and oxygen, and again silicon. So these are 4 oxygen atoms. It has giant covalent structure with each silicon atom bonded to 4 oxygen atoms. This is absolutely correct. Because in between, in the center, you have 1 silicon. In between oxygen means oxygen is connected with 2 silicon, and 1 silicon is connected with 4 oxygen. That's how this structure is made, basically. So this should be absolutely correct. It is a simple covalent. No, it is a giant covalent, as I said. And its structure is similar to that of graphite. No, the structure should be similar to that of diamond. So B should be the only correct answer here. Number 7, if you are with me, the number 7, when 65 gram of zinc reacts with 32 gram of sulfur, 97 gram of zinc sulfide is produced. So if we write in the reaction zinc and sulfur, it is forming zinc sulfide. So when 65 gram of zinc reacts with 40 gram sulfur, the mass of zinc sulfide produced is still 97 gram. Which statement explains this observation? So you need to understand from these two, zinc and sulfur, one must be the limiting agent and another must be in excess. So some of zinc sulfide evaporates, the reaction rate is low, none of them, the reaction stops before it is complete. Zinc is the limiting agent. Since we are not changing zinc, so this one is 65 gram and this one is 32 gram. So you need to understand, since we are not changing zinc, zinc should be the limiting agent here. So zinc is the limiting agent. That's why it is like this. So sulfur is 32 and zinc is 65. If you look at the mass number, zinc is 65 and sulfur is 32. So 65 divided by 65, which is 1 mole, and 32 divided by 32, which is 1 mole. So zinc is the limiting agent in both cases. So in case 1, you can say sulfur is also the limiting agent, but means in scene 1, both of them are 1 mole, so 1:1 mole ratio. But in the second scene, we can see zinc is 65 gram, which is 1 mole, but sulfur is 40 gram, which is more than 1 mole, right? So zinc is the limiting agent. That should be the only correct answer. Next point, 8. Aluminium reacts with iron 3 oxide to form aluminium oxide and iron. Okay, aluminium and iron 3 oxide. So which chemical equation for the reaction between aluminium and iron 3 oxide is correct? So you see iron 3 oxide is Fe2O3. So aluminium, if reacts with iron, then aluminium oxide and iron, if you look at number D, it is balanced equation. So D should be the only correct answer. So aluminium and iron, aluminium is more reactive than iron according to the reactivity series. So aluminium will displace iron from iron oxide, and you must balance the equation. So that's why C is not the correct answer. D is the only correct answer. And for A and B, these are all wrong chemical formula for iron oxide and aluminium oxide. So number 9, the concentration of a solution of aqueous sodium hydroxide is 0.5 mole per dm cube. So this is aqueous sodium hydroxide. Which mass of sodium hydroxide is used to make 500 cm cube of this solution? So you need to understand one thing from this. This is the concentration they're asking for. So if we write, you see 0.5 mole per dm cube. What does it mean? To make 1000 cm cube solution, you need exactly 0.5 mole. So you see, to make 1000 cm cube, this means 0.5 mole per dm cube means 1000 cm cube contains 0.5 mole. So they're asking for 500 cm cube of the solution. For 500 cm cube, what you need 0.5 divided 0.5 into 500 divided by 1000 mole. So which is basically half of this. So half of 0.5 is 0.25 mole. So if it is 0.25 mole, 1 mole of sodium hydroxide, if you calculate the RFM, it is 40 gram. So we are looking for 0.25 mole to dissolve. So 40 times 0.25, which should be 1/4 of 40, means it is 10 gram. So 10 gram should be the only correct answer. So that is how it goes. Next point, number 10. Molten zinc oxide is electrolyzed using inert electrodes. Okay? So zinc oxide, and it is molten, is electrolyzed using inert electrodes like graphite or platinum. Mostly graphite we use as electrode, inert electrode, which identifies the product at each electrode. So for molten zinc oxide, what you need to do is, firstly, you have zinc 2 plus ion and oxide ion present here. So now, if you look write cathode and anode equation, how will write? So cathode and anode. See, cathode, cathode, the name cathode is after cation. So cat has pause and cation is positive. That's how we remember. So your cation will go to cathode always. So zinc 2 plus. What is the problem with zinc 2 plus? It has 2 electrons short. So you give these 2 electrons. So zinc metal will form, right? And you see, oxide is the anion, so it will go to anode. So O2 minus will lose. See, what is the problem of O2 minus? It has 2 electrons extra. So if it loses 2 electrons, it becomes oxygen, right? But oxygen is always diatomic. Basically, all the gases we are studying in O-levels chemistry, these are all diatomic, like nitrogen is diatomic, fluorine is diatomic, chlorine is diatomic, so oxygen is diatomic. Even especially all the nonmetals like bromine is Br2, iodine is I2. So most of the nonmetals we are studying in O-levels chemistry are diatomic. So oxygen is diatomic. So in order to write O2, you need 2 oxides. So if one oxide loses 2 electrons, 2 oxide will lose 4 electrons. So 4 electrons it will lose. So oxygen gas is producing. So at cathode, zinc is produced. And at anode, oxygen is produced. So C is the only correct answer. Right? Very good. Next point, number 11. Number 11, dilute aqueous sodium chloride is electrolyzed using platinum electrodes. Platinum electrodes. And what is the half equation for the reaction at cathode? Again, dilute aqueous sodium chloride. So it is dilute. This is number 1. Number 2, it is aqueous. So if we rewrite sodium chloride, dilute aqueous, what are the ions present that we need to find first? Number 1, sodium ion is present, chloride ion is present since it is sodium chloride solution. Then since it is aqueous, we have hydrogen ion and hydroxide ion hidden behind, right? So that's you need to remember. If you have in any aqueous solution, you need to consider the hydrogen ion and hydroxide ion coming from water molecule, right? So what is the half equation for the reaction at cathode? So they are asking for the reaction at cathode. So as I said earlier in question number 10, cathode, cation will go to cathode. That is the point. So cations, we have how many cations here? You see, if I change the color of the marker, we have sodium ion and hydrogen ion. These are 2 cations we have. So from sodium ion and hydrogen ion, you know the principle. What is that principle? For cation, which cation will go to cathode? The principle is you have the reactivity series. So the metal, if the metal we are discussing here, sodium ion, so the metal ion, if the metal ion is above hydrogen in the reactivity series, then that metal ion will never go to cathode. Instead, hydrogen ion will go. That is basically the principle that you need to remember. So again, I'm saying if the metal ion we are discussing here is above hydrogen in the reactivity series, that metal ion will never go to cathode. So sodium ion will never go. So who will go? It is hydrogen ion. See, the problem with hydrogen ion is it has 1 plus charge. So we are giving 1 electron to it. So hydrogen is forming, hydrogen atom is forming. But hydrogen is not monatomic. It is diatomic, like any other gases we have in O-level syllabus. So it is a H2. So in order to write H2, we need 2 hydrogen ion and 2 electrons need to be added. So it is hydrogen gas which is forming. So A should be the only correct answer. Right? So see, they're giving very complicated molecules. This chloride and hydroxide will never go. Sodium ion will never go, as I said, the reason. Okay, question number 12. Hydrogen oxygen fuel cells can be used to power vehicles. Which statement about hydrogen oxygen fuel cells is correct? The equation for the overall reaction is hydrogen plus oxygen is hydrogen peroxide. So it is not hydrogen peroxide, rather it is H2O. So A is not correct. The only chemical products are water and carbon dioxide. It is not carbon dioxide. Only chemical products are water only. So hydrogen and oxygen will react together to form water. This is hydrogen oxygen fuel cell. And that's why hydrogen oxygen fuel cell is a very environment friendly, very green battery. Chemical energy in the fuel is converted into electrical energy. So yes, chemical energy is in the fuel is converted into electrical energy. That is true. We are generating electricity from chemicals. So in that, from that perspective, this is true. Number D, the hydrogen used in hydrogen oxygen fuel cell is a fossil fuel. No, hydrogen is not a fossil fuel. You cannot get hydrogen in the fossil, right? So D cannot be the correct answer. So C will be the only correct answer. Next point. A reaction pathway diagram is shown. So you know progress of reaction in x-axis and energy in y-axis always, and reactants and products are given. Which row identifies the type of reaction, how the temperature of the surrounding changes during the reaction. So you know, if say for example the energy level of reactants are 100 and the products are 400, so you see you need to give or add positive 300 kilojoule energy in order to make the product. So since it is positive, you need to give energy, so it is an endothermic reaction for sure. And temperature of the surrounding. So if you give energy from the surrounding, temperature of the surrounding will decrease because you are increasing the temperature of the system. So you are giving energy from the surrounding, you are taking energy and you are putting into the system. So the temperature of the surrounding should decrease. So A should be the only correct answer. Okay, number 14. If we go, the average bond energy for the CH bond is 413 kilojoule per mole. What is the enthalpy change when one mole of methane molecules is formed from carbon and hydrogen atoms? What is the enthalpy change? So carbon and 2H2 hydrogen will give you 1 mole of methane molecule. So what is the enthalpy change? So you see, we know breaking bond needs energy and making bond releases energy, right? So you see, you have CH bond 413, right? So enthalpy change should be carbon. The enthalpy change for carbon should be 0. Now, what is the enthalpy change when 1 mole of methane molecules is formed from carbon and hydrogen atoms? So you have carbon and hydrogen. Oh, they said atoms. So that's what I'm looking for. I was looking for. So it cannot be hydrogen. It is H, 4H atoms, right? So the bond energy should be 413 times 4. And, making bond releases energy. So it will be a negative thing. So negative 413 for 4. So they're asking for, again, what is the enthalpy change when 1 mole of methane molecule is formed from carbon and hydrogen atoms? So it should be negative 1652 kilojoule. So negative 413 into 4, right? So number 15. Which statement describes the effect of adding a catalyst to a chemical reaction? Which statement describes the effect of adding a catalyst to a chemical reaction? So if we add a catalyst, the rate of reaction increases. The activation energy of the reaction increases. No, it decreases. So this is incorrect. The enthalpy change of the reaction stays unchanged. Yes, this is true because catalyst cannot change the enthalpy of a reaction. So the reactant and product will remain same in their position. So the enthalpy stays unchanged. That should be the only correct answer. The frequency of collision between the particles decrease. No, it increases as um, frequency of collision. It can increase because you are adding a catalyst. The kinetic energy of the particles increases. It's not because of the kinetic energy of the particle. Rather, we know catalyst gives a pathway which involves lower activation energy. That's why it works. So 15B should be the only correct answer. So for today, we are doing up to number 15. We will inshallah start from 16 in the next episode. Thank you. Hello. Hello, students.